quick, quiet. Very quiet. Quiet. Um, for like practice problems to review, um, I would study any homework problems I've given you, and worksheets on solving trig equations, sum and difference identities. Just hopefully you've kept a good notebook and you know what you have. But I will probably also actually use the book this time in the review. There's at the end of the chapter, there's a review of the chapter, and then there's also what they call a chapter test, which I don't know if some teachers actually give that to anyone because it's right there in your book. But anyway, I'll pick some good problems off of that so that you don't have to pick and choose what, um, you maybe even spend time working on a problem that I wouldn't care a whole lot about as your pre-cal teacher. So I'll give you a list of things most likely from the chapter review and or the chapter test if you wanted extra stuff to study in addition to what you already have. And I think everybody knows how to click back through previous assignments or go to the monthly calendar view so that you can see everything we've done since the last test. The test will be on solving trig equations. Just a second. Sum and difference identities and double angle identities. And your quizzes, the juniors, you'll be gone unless you're a Marymount senior during the block that I usually teach my afternoon class. And so that's all the juniors. So I feel pretty sure that I don't think I'll anybody in class. So maybe I'll grade your quizzes during that block. So later on today, if you want to come back and get your quiz, or you can come by Monday and get your quiz, whichever, so that you can look over that to study for your test on Tuesday, okay? If you've not updated your memo page, that probably means you didn't watch the little video that I stayed here and you could tell I felt really bad late afternoon, Wednesday making it or whatever. But you either need to watch that or I would highly suggest it if you haven't seen it. It'd just be good review for anything that would be on the test because I do a little bit of each of these things. But mainly there's a point in there that we update your memo page. And you've got to know everything on your memo page for the test on Tuesday, okay? It's a memo page. We should be at the point really where if I say cosine of pi over 2, you say 0, to where you're not just looking at your charts all the time. Those charts are supposed to help you memorize things. Okay, let's go to like the homework in the book. And did anybody have any questions on the homework problems I gave you in addition to studying for the quiz? 17? Yeah. All right. So, and Katie, I forgot what page I gave you. Was it 381? 390. Okay. All right, so this is number 17. Is sine 4x equals negative 2 sine 2x. And that's a 2, that's not squared. All right, I always want to use identities to get it to where I can solve it, even though granted I could punch this in the calculator and solve it if I'm really like one day needing this as an engineer. But it's really, I think we all feel better if we solve it by hand and we just feel more sure of ourselves. So girls, let's be quiet. Obviously, you don't want to talk over anybody. There's a way I can get them both to say sine 2x using the double angle identities. It's a great question, Kate. On your double angle identities, I'm going to write it as sine 2u, as 2 sine u cosine u. Probably on your memo page, it might say sine 2a or sine 2x. I've forgotten what I used. Once you're introduced to U substitution, we use it a lot in pre-cal and calculus, okay? It means, like, in my class sometimes I say blob, like B-L-A-H, like whatever, okay? So here's U and here's 2U. What if U is 7? Then what would this be? 14, okay? What if U is 3A? Then what would this be? 6A. It's a double angle identity, okay? So, sine 4x or sine 2x, there's a couple of different ways to look at this. First of all, before I work it, they might get 17. I just am curious to see. They might work 17 and felt like you did it correctly.
Wait, that's the sine 4x.
Okay. So I'm going to make this sine of 2x like this. I notice I have some double angles going on. That made me think of the double angle identities. So right now I'm counting this for a brief moment as U. So if I have sine 2 blah, it equals 2 sine blah cosine blah. Okay? So do you see this as sine of 2 times 2x? So according to my pattern, sine 2 of anything can be 2 sine u cosine u. So what's being doubled? If I have 4x, what's being doubled? 2x. Let's pause for a minute and see if you can do another one. What would sine of 6x be? It would be sine of what doubled? 3x. And so I have sine 2u equals 2 sine u cosine u. So if this is 6x, 3x would go right here. Okay? Let's let x be 10 degrees and look at what's happening here. If x is 10 degrees, that should tell me the sine of 60 is equal to 2 times the sine of 30 cosine of 30. Let's see if that's true. Sine of 60 is square root of 3 over 2. Sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. It works, doesn't it? What am I going to do with sine of 8x? What's being doubled? 4x. So that's 2 sine 4x cosine 4x. So you might know how I could rewrite this. 2 sine 6x cosine 6x can be condensed. Do y'all see it's 2 sine u cosine u? I could write that, Katie, great, as sine of 12x. You could smash that together using your double angle identity. So you could stretch it out or put it back together depending on what you need. So in this problem, I saw this sine 2x, and I know you may not have seen it the first time you saw it, but now do you see this is a double that? So I went to my double angle identities, and I thought, well, 4x is twice 2x. So I changed it to 2 sine 2x cosine 2x equals negative 2 sine 2x. Now, the worst thing you can do right here, maybe, is divide this by sine 2x to cancel things out. I say that over and over again, and then Mr. Hill and I both see people do it, like on quizzes and tests. If you divide by sine 2x, you just open a window and throw out some good answers, okay? If you could divide by it, what could you do instead? You could factor it out. If you feel like you could cancel something out, you also could have always factored it out. So I'm going to make this 2 sine 2x cosine 2x plus 2 sine 2x equals 0. All right, what would I do next? If you could read my horrible writing. Great. Let's factor out a 2 sine 2x, and that leaves me cosine 2x plus 1. So now I have 2 sine 2x equals 0, and cosine 2x equals negative 1. So you see now how our problems build, because now I'm kind of back at a place I was before this section. So now I have sine 2x equals 0, and I'll just rewrite this one for some reason, I'm not sure why. So now I'm going to think of this as sine of u equals 0. Sine is 0 at 0 and pi. I'm going to look at where cosine u is negative 1, which also happens at pi. So I already have that one. And on this section, we're finding all the answers from 0 to 2 pi. So these should be the only two. Oh, I'm not finished. My goodness. I never went back. All right, so u was 0 and pi. But I need to put the 2x back in. So my answers for x are 0 and pi over 2. I think I need one more. With the 2x, how many times did I tell you to go around? Twice. So if I go around twice, here's 0 pi. What's this one? 2 pi, 3 pi. That's another rotation. Divide them by 2. Do you see I would have missed those answers if I didn't go around twice? I can check them just a minute. Okay? So think about this now, double angle identity. If I see sine 4x, I can make it a double angle identity. Okay? It's double 2x. Elena?
How do you know again, like, to go, to have 4 values for you?
Oh, back to like what you did on the quiz today.
Yeah.
If you're using new substitution, but it's 2x, and you're doing it on a limited domain,
Oh, it's about
you gotta go around again. You know, if it's 3x, you go around 3 times. If it's 4x, you go around 4 times.
Oh, I was just doing it until like, well, that's pretty much just doing it until like your 2x or like 3x, whatever it is like the greatest it can be, but not greater than 2 pi, right? Like that's what that does. Is like.
This is like the problems we worked earlier in the week when you get to this point. Like, if I had, cosine of 3t equals square root of 3 over 2, and I want all the answers on 0 to 2 pi. I'm going to go cosine u is square root of 3 over 2. And I'm going to start listing what I can think of for u, which would be pi over 6 and 11 pi over 6. But if that's cosine 3t, that's a way shortened period, so I haven't gone far enough yet. So I need to go around again and again. So that's what I was doing. And at the end, when I divide them all by 3, it smashes them all back down. So when I had cosine of 2x equals 0, I'm thinking of cosine u equals 0. That happened at 0 and pi. I must not have had cosine 2x equals 0. Anyway, if I had that, that would happen at pi over 2 and 3 pi over 2. But with a 2x on a limited domain, I better go around again and then divide them all by 2.
Yeah.
Okay? So Katie, when you see stuff like this from now on, you can probably use a double angle identity, especially if there's a 4x somewhere in the problem. Look at this one. So it'd be cosine of twice 4x. For cosine 2u, there's 3 possibilities that you can always pick and choose from. cosine squared minus sine squared, which morphed into 1 minus 2 sine squared. This one also morphs into 2 cosine squared minus 1. And so say I wanted to use this one. Then I could change this into 2 cosine squared 4x minus 1. Do you see how cosine 8x, if that's an 8x, this would be a 4x. All right, let me talk about this since I'm just running at you. That's so important to AP Calculus BC. Or if you're going to go into AB, chances are super high you'll still be in Cal 2 later, just not at Marymount, okay? So one way or another, you're going to need these, okay? If my one of my BC students walks in and I ask him to integrate that, or you know what, just ask me to integrate it, even if you don't know what that means, it's something you have to be able to do in Cal 2. If you ask me to integrate that, I can't. But I can integrate that or that. So do you see I need to know how to change something? You can already see on a lesser scale why I really would much rather know that sine over cosine is tangent. Because that's one thing to work with. Set 2. I know you don't understand why I could do one or the other, but that's not important. How do you make your decisions now? Is if I'm working a problem that has the word sine in it, I'll choose this one. If I'm working with a problem that has cosine in it, I'll use this one. I actually hardly ever use this one. So why is it sitting there? Sometimes I use it, occasionally, okay? But these two came from that, didn't it? If you remember, I made this cosine u plus u. So cosine A, cosine B minus sine A, sine B. So like it derives into this, and then we use Pythagorean identities to get these two. Okay? So you need to know all three so you can see which one to pick. There are a lot of you in here that you just have this one memorized. Because you realize you could just change it to either one you wanted to yourself. You all see what I mean? If you don't need that, you could change that to 1 minus sine squared and get this one. But I just leave that up to you. When they appear on memo quizzes, which you probably have a few after Christmas, we might have one more before. What would happen on a memo quiz is I would write cosine 2u, and then you could pick which one of the three you want to write down. And any of them would be okay on the quiz. You wouldn't have to work anything out, you just write it down. Okay? Danielle?
I have a question about next semester and the memo quizzes. Because this semester you took our best 5, but if we don't have that many, is it just you take all of them?
We'll just make a new agreement. Okay? We'll come up with a new plan.
When do you know to use the like these? Like when would you use it?
Well, I just wanted to use it on a problem that they didn't tell me to use it on.
Okay.
I had a 4x and a 2x. Well, I had a 4x and a 2x, so I thought with double angle identities, I can get it all to be a 2x.
Okay.
If I have an 8x and a 4x, I'm going to go to the double angle.
But it's like when you're solving for x or like when you're...
Or it happened here, in a problem similar to this on your homework. If I want to know when that's true. Now, think about common sense of what this is even asking you. It's asking you, is there ever an angle that you take the sine of and double it and get the same answer? Like it doesn't happen with 30 and 60, does it? Okay? But so, Elena, I would want to change that to 2 sine x cosine x.
Mm-hmm.
So I'm going to use my double angle. Did you see a double? Okay. So I would want to make this 2 sine x cosine x. Subtract the sine x, work it out, and I'll find out. Okay? So I understand your question, and the best way I can answer it is like saying, and girls, this always happens, so listen carefully. Especially those of you that take BC, and you'll see something that'll happen there. You don't ever, like, ask me that question for something like this. you know you need the Pythagorean identities
Right.
to get from one to get out of that situation, okay? Or if you have this, you know, something like that, you know you're probably either going to change cotangent or change sine over cosine, okay? It's just you haven't worked with these very much, and you've worked for these for a long time. So it's the old thing in teaching that I teach you this body of material. So I teach you like the quotient identities. I'm sorry, the reciprocal identities. Then I teach you the quotient identities. Then I teach you the Pythagorean identities. By the time I get to the double angle identities, I'm pretty much done with trig. And then your calculus teacher's yelling at you like, why don't you know the double angle identities? It's because you learned them last, you didn't use them very long. Which you can say to me next year when I'm yelling at you, okay? Because I'll be doing it kind of in jest to, just kind of joking around to make sure you gotta know them. Like you gotta learn. If you learn the Pythagorean identities last, then you'd be great at the double angle identities.
So you're just.
So this is the nature of our minds, really. It's not the identities. It's when they come up.
Okay.
So the answer to your question is, you would instinctively know. If you had a chance to work on them a lot more, it would just pop in your mind. Right now, I'll have to make sure I structure the test to where you should recognize what you need to do. Okay? And they didn't really say anything there, but I guess you're in the section where you just learned the double angle identities. Let's go to this one. In the homework, number 13. A few of y'all asked me for 13. 13 was 4 sine x cosine x equals 1. No wonder you emailed me about that. You could feel really stuck there. Okay? By the way, while I'm thinking about it, some of you know that this has come up between us before. Don't ever do this. I see people do that. Please don't make me think. I sure, if you're looking at that like that's, why would I do that? Please stay on that and don't even listen to me. But you want it equal to 0 before you factor. Okay? Because if that's 0, either this one has to be 0 or this one has to be 0. But if that's any other number, does that have to be anything? In fact, you're going to miss it. You don't want that one to be 3 and that one to be 3, then you would get 9. Y'all see what I mean? Get it equal to 0 before you factor. Okay? Alright, I'm sorry, I just thought of that out of the blue. Alright. So, Elena, that was so familiar to me, but I've done a lot. You're just learning them. And that was a lot like sine 2x equals 2 cosine x cosine x. Right? Okay. So could I make this 2 sine x cosine x? So I have 2 times sine 2x equals 1. So I see that I have 2 sine x cosine x built into this. So what would I do if I had 6 sine x cosine x? And this is back to Elena's good question. If you had 6 sine x over cosine x, you'd say 6 tangent x in lightning speed. You're not used to seeing them next to each other. That's always sine 2x if they're next to each other. If they're divided, it's tangent. If they're next to each other, it's always some form of sine 2x. Would this one be 3 times 2 sine x cosine x? Okay? So to finish this problem, I'll divide by 2. And I get sine 2x equals 1/2. And then I would go sine u equals 1/2. U is pi over 6 by pi over 6. And this was solution 0 to 2 pi. So I go around again. I'm adding 12 pi over 6, 2 pi. So that's 13 and 17. And then I divide them all by 2. Bella? Question?
Oh, I thought that the stuff on the other side of the green was like part of that problem. But it's
No, I drew that green squiggly line just so I could talk over there on the other side.
so you want to try to get it to sine 2x. Like if you have sine x cosine x, 2 sine x cosine x.
You like sine 2x. You like, it's really, I mean, like, I probably could figure this out. Okay? But I don't want to. I don't want to, if I try to find a sine, then I multiply by a cosine to give me 1/2. I'd rather go to the double angle identities. A single trig word is like gold. Okay? All right, now, any other homework questions before I go on? Zane, I feel like there was something we talked about that I was supposed to do. Was there anything that I was like, remind me to? I feel like you asked me a great question earlier today.
It was
Okay.
just about the reading time, I think.
Maybe that's what it was. Real important, yeah. Hey girls, wait. Listen. Singers, if you're leaving, I'm sorry, you will be leaving. Okay, singers who are leaving. I would say it's ultra maximally wonderfully important for you to watch the last, what do we have? Okay, so just, you just fast forward and see the last 5 minutes, okay? All right, now, girls, listen up though, no talking in 5 minutes, because I want to get a couple of really good things done, okay? So,
Thank you.
you're welcome. All right, what if I want to find the sine
No, I say we just keep the same as always. Such a small class.
cosine and tangent of 13 pi over 12. You don't know anything about over 12s, okay? Elena, we hadn't made out the test yet, but chances are high that maybe it would have a section that says use the sum and difference identities, okay? So let's say I know I'm using the sum and difference identities right now because I don't know anything about 13 pi over 12. You've done this in degrees on a worksheet, okay? But if you're in radians, could I do 8 pi over 12 and 5 pi over 12? That wouldn't do me any good because I don't know 5 pi over 12. 8 over 12 reduces. So you got to come up with two things that'll reduce. And it doesn't always, like Rebecca's might be different from Isabella's, okay? But you should get the same answer. What if I do 10 pi over 12 and 3 pi over 12? Then that would be 5 pi over 6 and pi over 4. I could pull that off, couldn't I? So I could say sine of A cosine B plus cosine A sine B. Sine of 5 pi over 6. You do have to think about all of your signs. Are they positive or negative? That would be 1/2 root 2 over 2. Cosine of 5 pi over 6 is negative root 3 over 2. Sine of pi over 4 is root 2 over 2. As expected, I'm going to get some form of square root of 6's, square root of 2's. This one's going to give me square root of 2 minus square root of 6 all over 4. All right, now, for cosine, you would use cosine A plus B, cosine A, cosine B minus sine A, sine B. And then what do I suggest you do for tan? Put sine over cosine. Scale back through your test and see if I ask for sine of 75, chances are high that you've already found, tan of 75. Look back for sine of 75 or wait and look ahead till you find this. Okay? Now, what if I then wanted you to find stuff for pi over 12? You could use 4 pi over 12 minus 3 pi over 12, right? And then you could find sine, cosine, or tangent. But look at where pi over 12 is. Okay, it's half of pi over 6. It's 15 degrees. Where was 13 pi over 12? What quadrant? 13 pi over 12? Okay. Same reference angle. So it should be the same answer, but what? Negative. If you want to notice things like that, I said that at the end of the last class too. Most of y'all are going to want to just work it all the way out because you're going to be nervous, okay? But look for things like that. I don't even care on my test. Maybe different in Mr. Hill's room. If you come in here knowing that pi over 12 is the same as 15 degrees, and 5 pi over 12 is the same as 75 degrees, and you want to just copy down your answer from what you already found, I'm good with that. I think that's very, very smart, okay? So anyway, I'll give you a list of things to study from a few pages in the book that would be optional. If you study everything I've given you so far, you'll be fine. Okay?